Good afternoon and welcome to the FAA's Air Traffic Control Tower Standard Design presentation. Thank you so much for joining us today. I'm going to hand it over to Jeff Planty, the Vice President of Technical Operations, for opening remarks. Take it away, Jeff.
Thank you. Hello, everyone. I'm extremely excited, as is our team, to be here to talk about sustainable towers and be part of this event and to provide some opening remarks. So just going to jump right in. So as some of you may know or may not know, the FAA currently maintains more than 100 regional and municipal control towers that are well over 40 years old, which is really beyond their intended performance life of 20 years. Using the $2 billion in funding provided from the Bipartisan Infrastructure Law, or bill, the FAA committed to replace 30 of these facilities by 2030. That's right, 30 by 2030. Now, the agency and our team are experts at replacing 1 to 3 towers per year, but replacing 30 towers in 7 years requires a new approach. We needed an innovative design that could not only meet our operational needs, but could respond to varying heights, differing climates, and withstanding hurricanes and earthquakes, and also prioritizing efficiency and sustainability of the agency. When faced with similar situation in the 1960s, the FAA held a design competition in which we accepted IMPA's design for a multi-tower prototype. Those are some of the towers that we have still in existence today. Those tower cabs were factory built and hoisted onto the tower shafts, incorporating a modular concept. Similarly, we recently held a design competition structured in 3 phases identify an innovative design and construction solutions to meet our challenges. Phase 1, that was the competition which generated 40 design concepts from worldwide audiences. 16 of those concepts were advanced to phase 2, in which the team qualifications were evaluated. 6 concepts were provided into phase 3, in which the concepts were further developed into a 10% design. POW, practice for architecture and urbanism, won the tower design that can be deployed throughout the United States while maintaining key sustainability goals, including, pretty impressed with this, all electric building design system, maximize daylight, maximize occupant well-being, a thermally efficient facade, high use of recyclable and renewable materials, renewable mass timbers when usable, ground source heating and cooling in some of the environments that these towers will be deployed in. POW is currently on track to deliver the first standard design package early 2024, I believe, and we have Visham here to talk about that. And it's my pleasure to introduce Visham Chakrabarti, a fellow of the American Institute of Architects and founder and creative director of POW. Visham, over to you.
Great, thank you, Jeff. It is such an honor to be working on this. We're still peeling ourselves off the floor at the fact that we won this. We know we had intense competition. We had a great amount of guidance from your team, and it's just an extraordinary honor to be part of this process. So I think we're here to kind of dive in and talk about the design. And also, I was asked to give a little bit of personal background, so I'm going to do that as well. So happy to start the slides whenever we're ready. And first, it's not just POW, Practice for Architecture and Urbanism. It's a big team, and I'll talk about that a little bit, including Thornton Tomasetti on structural engineering, JB&B on mechanical engineering, fire protection, Conoco on cost estimation, and so forth. Just to give you a little bit of background. So it's interesting. I was reflecting on the fact that it's almost exactly 30 years ago that I entered architecture school. And I was kind of ambivalent about it, because this is what was going on in architecture at the time. It was sort of more is more, right? It was the exuberant 90s. And I was kind of worried about this being the future of architecture, because we had multiple crises going on even then: climate change, inequality, artificial intelligence. You remember this is HAL's Eye from 2001. So people have been worried about this for a long time. And population growth as it relates to all of those things. And, the fact that I believe that the way to address all of these things, and I think these towers play a role in this, is the creation of community. That basically when we create strong communities, we can solve any problem. And when we can do that with a sense of density, even in small towns. So at all scales, we're super interested in community building. and how you create communities out of diverse populations. And that, to us, it is not at all about big cities. One of the things that interested us so much about this competition was that a lot of these towers are going to be built in very small towns across rural America. And we believe that those small towns also need help building community, just like our big cities do. And so that's what we try to do. We try to imagine that every piece of architecture is connective. It builds a sense of urbanity, even in a small town. And that helps to build a sense of place and create a sense of pluralism and builds a better planet. And a lot of that in our minds has to do with infrastructure. We think infrastructure is the connective tissue of community. And that means not just traditional infrastructure, but housing and walkability and all of these things. And again, I'm going to explain why this relates to this tower competition in a minute. So before I started the firm POW about 8 years ago, prior to that, I had worked in New York City under Mayor Bloomberg, trying to do community building projects, rebuilding the World Trade Center after the events of 9/11, the High Line. Some of you may have visited some of these, and that's been a lot of my life's work. And I've written about it, and that's our office today. A lot of your FAA team has visited our office in New York. It's a community in its own right. And so we came out of the box kind of saying, this is what we wanted to do. We wanted to build humanist architecture and build communities. And so that's what we've been up to. We've been doing that in a lot of different places. We're expanding the Rock and Roll Hall of Fame, which I'll talk about in another I Am Pei building. Pei comes up again and again in our practice. And we're about to open this pavilion in Columbus, Indiana, which is also about community building. This prize we won, again, in a small rural town in the middle of the country. And with all of our work, we have a motto that we work with places to understand them. We understand client and community needs. And through that, we create a sense of connection. And by connection, we mean connection in terms of architectural form, materials, technology, climate, and culture. And so, again, it's interesting. We won this competition to expand the Rock Hall, which was an I Am Pei building in Cleveland. And so this thing from Pei to Pow has become kind of this funny motto in our office, something that we think about. And so, when this competition came along, we said, we have to enter this because of the legacy of I Am Pei. I Am Pei, of course, won, as Jeff was talking about, this competition in 1962. I believe 16 of these towers were built nationwide. And I have this Pei book in my library, and he wrote for this competition that everything you see is the result of a purely functional requirement. And the functional requirements have changed tremendously since those days. People didn't talk about sustainability. Just if you look at the image on the right, the amount of concrete that was used back then, we try to use more sustainable materials. But the philosophy is the same. We wanted this prototype to really evolve from function. And that was Pei's idea as well. The other thing that was really important to us was acknowledging the fact that we weren't building the tall towers in the big airports around the country. These were small, from roughly 60 feet out to 119 feet towers in small communities all across the country. And that we really wanted to acknowledge that and work with that scale. So what's interesting is this is shown as like no program except for the cab. And you see Chicago O'Hare, that is a Pei tower actually from that competition, but that we're much shorter than those really slender, graceful towers. So our original proposal, so we thought about, I've driven cross country 4 times. It's a beautiful country. And about the expanse of the American plains. And, one of the famous architects who responded to the plains was Frank Lloyd Wright. And he was all about the horizontal. His buildings were all about the horizontal. But there's another idea out there about how you respond to the American landscape, which is the vertical. This is a very famous architect, Bertram Goodhue, who did the Capitol building in Lincoln, Nebraska. And he believed that punctuating the American skyline with these points of verticality was very important in terms of who we were as Americans, that we were ambitious, we aspired towards the skies, right? And so when we think about these towers, we think about the fact that in many communities, they will be the tallest thing. And so going back to my sort of introduction, we believe these towers help to build community. They help to sort of understand that we all belong to one place. And so it was with that in mind that we did the initial phase 1 competition brief. We obviously had very little program information at that point. We were very focused on sustainability in these initial designs. And we're interested in those more slender forms that you saw in those taller towers. But you can see here that we barely understood the program back in the phase 1. We were trying our best, and we were, as I said, focused on sustainability and constructability. One of the things that the phase 1 brief had laid out is that we wanted to be able to build this in 10 months. These were FAA leases on municipal airports. We wanted to be able to do it quickly, and that we wanted to use as little embodied energy as possible. So trying to use as little concrete as possible. And so we were very focused on that set of kind of ideas, and Thornton Tomasetti was there with us from the beginning on that. But then, as we started to understand that this was going to be a prototype scale that did not have an ancillary base building. Like we were just out at the Teterboro Tower, which has a base building, and realized that in many of these airports, we were going to try to incorporate all of the program necessary for the tower in the tower footprint. And so that you can see that in the competition minimum, that 60 feet or 63 feet or whatever that number ends up being actually has to absorb all of the base building program in kind of a more stout form, if you will. And that the competition maximum 119 still has a lot of kind of saddlebags associated with it in terms of its program. And so that phase 1 idea that we had, all of a sudden we realized by phase 3 that we needed to add a lot of program, both right beneath the cab level and then down at the ground level in terms of mechanical equipment and fire protection and so forth. So one of the things that we did at this point is, and it's a little unusual, is we actually scrapped the original idea. And we said, we have to go back to the drawing board. This is a new program. We have to understand this in a fundamentally different way. And so we started looking at saying, well, how could we jam that program into the old building? And suddenly we came up with this hourglass form, and it just didn't look right at all to us. It felt like, we were just trying to stuff too much into an old envelope. And the other thing is, we were very cognizant of the fact that you couldn't just look at the 119-foot tower. You always had to look at the 60-foot tower, the small tower, because the design had to work at the smallest scale. And it had to read as something that people would be proud of in their communities. And so, like I said, we went back to the drawing board and we did lots and lots of design work and tried to think about how can we incorporate all of this program into what is this kind of compact height. And like I said, and like pay, we wanted everything to be driven by function. So one of the things that we promised the FAA during our interview process is that there'd be no added sugar, but there'd be plenty of added flavor, right? So what this was going to be driven by in terms of sustainability, in terms of cost, in terms of ease of deployment and construction was the program. The 2 engineering disciplines that were sort of front and center for us, which was mechanical engineering and structural engineering. And as I said, that's JB&B on mechanical, Thornton Tomasetti on structural. And the 2 partners from those 2 firms are 2 of my best friends. We consider engineering to be really important to our discipline of architecture. We don't just design something in a vacuum and ask our engineers to figure out how to build it. We really collaborate with them upfront. And we felt that if we had the program right and MEP and structure right, that we didn't have to add anything really, that was the architecture in that classic form follows function idea. But that doesn't mean that there doesn't have to be beauty. And so we went, and some of you might have heard this reference that we call it the F4 tower. What F4 stands for is form follows function with flair. And what we mean by that is this set of precedents, which is the kind of water towers and lighthouses you see in communities across the country, where those are the tallest forms. They tend to be industrial. They tend to be kind of stout. but they're really beautiful because they are kind of stripped down to their most elemental engineering facts and needs. And that's where we wanted to kind of start from in terms of a new design. And we also had some other precedents here. Famously, R2-D2 from Star Wars had this ability to telescope, so it could go from 60 feet to 119 feet, and that notion that the tower had to telescope across heights. And so we arrived at this idea of, this is one of my favorite images, and it's the image that we're using for our background right now. And again, this is the shortest tower. And what I always said to our team is, if the design doesn't work for the shortest tower, then it doesn't work, right? Because we have to really acknowledge the fact that in some cases, it's going to be quite a stout object in the landscape. But hopefully you see the resonance with those water towers and with those lighthouses that I mentioned earlier, and even little things like the lighting and the cab. Obviously the cab, there's very little design work we can do. It's a standardized cab, but just the small things, the railing details and so forth, that help it really be a beautiful thing in the landscape. And then of course, the fact that it could telescope to that taller height. And this woman is so enthralled with the tower that she's actually decided to cancel her journey and look at the tower for the next couple of days. So here you have it. And we have this model in our office, this little maquette that shows the tower that can deploy at all of these different heights. And we're going to talk a little bit more about what generates this. We started, I think, with an earlier tower that was at 95 feet. We're still trying to understand which is the first site adapted tower. So right now, as Jeff said, we're working on the prototype, but this was a model for a 95-foot tower. And so you'll notice there are some variants that we can use, like color, right? So color on that steel might be different from region to region because it reflects a state color or a state flag or something like that. So we have a little bit of regional variation with these prototypes. So basically, when you look at the building components, they're broken down very, very rigorously in terms of the circulation to get you up to the cab. That includes the stair as well as the elevator, and the elevator obviously can't penetrate the cab. So the cab has the 360-degree view of the airfield. The structure, which is both a structure on the outside, on the inside, that is the core, as well as an exoskeleton that is steel on the exterior. So there's both redundancy and the ability to manage loads differently. So if one of those columns gets taken out, the thing still stands. MEP and fire protection, and there's mechanical equipment throughout the tower. And then the main program support for the air traffic control tower, air traffic controllers, obviously closest to the cab. And we were, as was said, and we'll talk about this more, very concerned to make sure that that was easily accessible from the cab, had natural light. And we understand that air traffic control is a very stressful job, and wanted to make sure that we provided as much wellness as possible for the controllers. And so that's just an image when it's at that taller height up in the sky. And so the structure, we think the structure is very, very beautiful. Again, it's quite industrial. This shows you the exoskeleton, how the exoskeleton is assembled, and even little details like that pin connection and how it sits on the ground, because the exoskeleton is the major thing that's providing it lateral support, while the core is providing the gravity support. And then again, the building, I don't think I need to say a lot about this other than there is a 2N for the mechanical systems, meaning that there's a redundant system for every single system in the tower. So if a system goes out, there's always a backup system. And then things are distributed in terms of whether they want to be closest to the cab or closest to the ground and the points of entry down at the ground. And so just building the tower up from the ground, right? So there's a vestibule, there's some storage, and then going up, there's electrical and plumbing. And then up into the upper rooms, you've got some controller program rooms, as well as mechanical and electrical. And then the restrooms as close as possible to the cab at the junction floor. And then going up to the cab access floor. This is a really critical floor, as you know, because it's really a Rubik's Cube. It's quite three-dimensional in terms of all the wiring and equipment that has to feed the cab above it. It also absorbs the elevator overrun for the elevator, so that does not intrude into the cab. And then it has that outer railing so that the windows can be cleaned in the cab and so forth. So it's actually quite a critical level. And then you get, of course, up into the cab itself with the 30-degree unobstructed look down angle. And that is all quite standardized. And then you get to the roof. And so that's how you build it up. And then this is just showing it again in a couple of different contexts, in a more urban context. This is in a more southwestern context. And again, you can see how that slight shift in color changes the reading of it and changes the way it relates to what is quite a small airport. And then this shows you more at a seaside level location where maybe the use of the color changes to a blue. And then in a snowy place where you might want a brighter color. And so what that is about is saying that, again, there is a desire to build 30 of these by 2030. So we needed to make as much fixed as possible in terms of the modular system that goes into this. And then there's a series of things that are site specific, such as color, height, and then things that are kind of more technical, like material and labor supply and siting, and things associated with the local environment, like seismic, wind, and so forth, that are differing from location to location. And so this is just showing you that there are some varying things that can happen. We are trying to use some sustainable materials if possible, such as CLT, if we can reduce the carbon emissions of the construction. And then something to make sure that we understand about this is, unlike that concrete tower that you saw of Pays, which was very sort of singular and insular and couldn't be adapted, this has a structural redundancy that allows for expansion. So you can add a saddlebag if you need to. So there is a kind of modular kit of parts aspect to it. And I think you can see that more clearly here. And then that just gives you a close-up of the cab. Right, and then something that was very important is maintainability, so that over the course of many decades, that there's as little maintenance as possible. So things like the structure, what the architectural enclosure is, which is stainless steel, I'll talk about that, the MEP and other equipment. So the structure, you know, it is a weathering steel, and there's a couple of different options that you can see there, whether it's an intumescent paint or a powder coated paint that has a very, very high degree of maintainability. And with every single material, so this is a chart we made for the architectural enclosure that explains why we ended up choosing stainless steel as the outer panels, because it both had the maximum durability and the maximum sustainability. Right, and so that's just showing you how we kind of ended up checking those boxes. And then understanding that, like, not all stainless steel is the same, and that certain types of stainless steel are very important to use in more corrosive environments around salt water and so forth. And so you can see just the difference between two different stainless steel finishes and how they age differently, and watching for things like this so they don't happen with our towers. And then things like maintainability for the MEP. So all of the equipment can be brought through the building, through the elevator cab, through the existing doorways. So you don't have to get a crane and take off the building skin in order to maintain the mechanical systems. Just another couple of images there. And then in terms of sustainability, there were a number of things in terms of sustainability, but there are four main things. It is an all-electric tower. We're very excited about that. We're very excited about the potential to do ground source heating and cooling, or what's known as geothermal. We have looked a great deal at wellness, again, for the air traffic controllers in terms of daylighting and comfort systems, and then a high degree of recycled content. But then in addition to those four main ones, there's a number of other things that I'm not going to go through all of this here, but there's another number of other aspects of sustainability that we focused upon when looking at the design. And then in terms of construction, what you're seeing is the ability to ship most of this in a flat pack. and have the ability to erect it like an erector set on the site, so that this can get done within a 10-month time frame on a number of these sites. And so the modular aspect extends not just to how it looks, but literally how it gets built. And so we're hoping that the aesthetic of the tower kind of helps explain this erector set kind of system that the building sits in. And then we were concerned about life cycle as well, knowing that at some point these towers will get replaced and that they can get disassembled, and that there's an aspect of circular economy where all of the parts can get recycled. And so that just shows you that as an overall timeline. And then that shows the tower up in Alaska in the snow. And I think down in Los Angeles, although I'm not sure if that's a real image or just our imagination. And then just lastly, this is our last slide. And just, as someone who came here on an airplane as a child, I have this real romance for air travel. So we were all very excited to be participants in this. We really do believe it helps to build stronger communities and helps to connect us, because there is a magic to what you all do. And so we're just very pleased to be a part of it. So thanks very much for having us today. And Zane, I think you've got the final words here.
I do. Thank you, Vishaan. I appreciate it. And I just realized that you and I on Zoom at least have very similar beards, man. So well done.
There you go.
Good afternoon. I'm Zane Edwards. I'm the design and engineering team lead for the facilities group. I want to thank everybody for your time today, your interest in the Tower Design Initiative, and mainly really your patience with us as we've worked through what has been a pretty unorthodox process for our group. We know it's taken a bit of time. I think we're in a good spot now. So thank you for that. And, as Jeff mentioned, the bipartisan infrastructure law has provided us a tremendous opportunity to address some significant issues we have with our aging infrastructure. But with that, I have to say it comes with some pretty big challenges. And one of the key components to addressing those challenges is the development of what we consider a functional tower design. And the key way we make any design better is through collaboration. So what I'm asking you all to do, we are getting ready to see the very first formal submission from the PAL team here in the next few weeks. I would love for you to take a look at it. We'd love to get your feedback and your input. Please send that to your engineering services point of contact in each one of your service areas. We are very interested in hearing what you have to say. And I also want to, beard notwithstanding, I also want to thank Vishaan for taking the time to walk us through his philosophy and his team's creative vision for the development of the design. One of the things our team has been very excited about, and I think it came through in the presentation, but even for us from the very early days of the design procurement up to where we are now, is the PAL's willingness to take a look at new data and completely transform their design. I think you saw that in a couple slides where the design went from one thing to another thing to a final thing, which are very different. And so, watching them work has been interesting. And it's also another sort of bizarre thing, and I make a little bit of a segue, but we sit in a room with the PAL a lot face to face, and we meet with them. And what it has always reminded me of is growing up in the summertime in Virginia. I get that's a bit of an odd analogy, but give me a second and bear with me, and I'll sort of maybe bring it together. But my cousins and I used to go to my grandmother's house, right? And we would spend a bunch of time there, and inevitably we would ask her for creative ideas for something fun to do. And she was an old high school teacher, so her idea of fun was, well, here, I got a whole wall of books. Why don't you go over here and read them? Or I can come up with some, maybe some interesting math problems. You can work those out. And 7, 8, and 9-year-olds, by that point, we're turned around, we're starting to walk out the door. And, we had this little chant that we came up with, and it went something like this. Summertime is no time to use your brain. And we would, be walking out the door. But inevitably, before we got out, she would say the same thing every time. She would say, you boys go be creative. Creativity is just your intelligence having fun. And, working with the PAL team has been the embodiment of that to me. They continually present us with thoughtful and creative solutions to our unique design challenges that control towers have, their confined spaces. This is how we know we found the right partner, and this is why we are so looking forward to our continued collaboration. And we are super pumped about the final evolution of the PAL standard design. And I think you guys have heard me ramble enough now. So I just want to say thank you all for your time. I know you're very busy. I know everybody's excited to get this moving, and we are as well. So we will see you all soon.